Okay, I'm live with a 4-hour free Rust Bootcamp here and ready to get started and walk through all the material. I'll tell a little bit about the structure before I introduce myself. So I'm going to roughly talk for about 45 minutes or so, and give or take. So let's say 15 till the top of the hour, I'll just basically turn off, mute, take a break, get some water or whatever, and then I'll come back. I think that style for like a 4-hour training is what I like. So that's the structure, and I can even paste as well into the session here, basically the overall kind of style, a little bit of what it is that I'm thinking about doing. But I'll talk about it real quick. So first up, I'll talk about Rust. Uh, why do we care about it? How to set up a Rust environment. Also, Rust ownership and borrowing. We'll talk about that in the second half here, and then also we'll talk about Rust libraries and tools, and then we'll talk about combining Rust and Python together. So that's basically the general structure. Maybe I'll start with first introducing my background and talk about why you may want to listen to me about Rust and what's going on. So my career, I started in really the television and film industry, working in Southern California. And one of the things that I started doing as a teenager was working with live television and working with editing. And I saw the transition as a teenager from analog to digital technology, and some of the stuff I was doing back then versus what we're doing now is pretty funny because you can see that we can do things on a laptop that you couldn't even do with the most expensive, $1 million equipment back in, let's say, the 1990s. And so I've always been very interested in the transition from technology to, like what are the changes that are happening with technology and how are they actually occurring? And that's one of the things that I'm seeing now with both machine learning, and I'm also seeing this with languages, is that whatever was state of the art 20 years ago or 10 years ago or 5 years ago doesn't mean that it's going to be state of the art today. So that was really the intro. Then I worked at Caltech in the year 2000. I worked there for 3 years. I worked on a variety of things in the IT department, from building Unix systems, Linux systems, Windows systems administration. So a lot of what I did was systems administration, automation, writing scripts. I got a taste for Python. And then I went back into the film industry for about 10 years or so. So I worked Disney Feature Animation, building their first 3D animated pipeline as a member of a whole bunch of people. Also worked for Sony ImageWorks on building pipelines. And so that background was, I think, also very suited towards what I'm doing today. Believe it or not, about 20 years ago, is that in the film industry, we use Python for automation. And in fact, what I think many people don't know is that actually film 20 years ago is very similar to what we do today with data engineering. So you would write scripts that would move data into different locations. You would have network mounted file servers. You would have high performance computers. And it's very interesting, actually, I would say, how arrogant many people that are in data engineering are when a film person tells them, hey, we actually did a lot of the same things you're doing. And a lot of times people will dismiss it. And I think people in data engineering actually need to look back at the history and look at how film people have actually been the innovators in data engineering way, way before what we're doing now. And many of the same things and the same problems that occurred in data engineering today actually occurred 20 years ago in film. And so I learned a lot about large scale systems and Unix and Linux by working at scale where people have giant, $300 million budgets on films. And later I moved to New Zealand and I worked for Weta Digital, and I worked on the movie Avatar. So that's the thing that a lot of people know about. So if I say I worked in film, the one thing people care about is like, whoa, you worked in Avatar. So yeah, if you Google, Noah Gift Avatar, I have film credits. And so what I did there as well is just scripting automation. And it was a really good experience working on that movie. and living in New Zealand for a year. I then moved to the Bay Area, worked in the Bay Area for about 10 years, and went from individual contributor to engineering manager to essentially VP of engineering and CTO type roles. And then ultimately I worked with a lot of, I would say, cutting edge and large scale companies in the data space as well, from logging as a service companies to game companies to sports social media companies. And I also spent a lot of time actually making money for companies. So I got some experience with building products. So I have a background of knowing how to build stuff that works, and then also how to actually make money at it. And I think that's one of the reasons why I would call myself a pragmatist. And then simultaneous to that, I also have written 10 books. So that was something I wanted to do as a goal for myself, was to write 10 books that are technical books. And I'm now retiring from writing technical books, but I wrote 5 for O'Reilly, 1 for Pearson, 4 of them self-published. And the topics typically are data engineering, machine learning operations, cloud computing. So a lot of the stuff I did in my career. And then since about 2017, I started teaching part-time at different universities, UC Davis, which I still teach a little bit part-time, Northwestern, their graduate data science program. Also currently at Duke, I'm an executive of residence. So what it means is that I teach a little bit, like, a couple times a week, but mostly what I'm focused on is content. But with Duke, a lot of the stuff that I'm doing is actually related to Rust, and also to large language models, and also to cloud computing. So that's my background. Also say that in terms of content, if some of the stuff that we're doing is interesting to you, feel free to actually go to Coursera. I have actually a lot of content on Coursera around these topics, including cloud computing, data engineering, machine learning operations, Rust. And I've at this point have the equivalent of I think a master's degree of content created, which just feels kind of cool. Is that along with other people that have collaborated with me, I have effectively created a master's degree of like vocational style technical content, and I'm still going with Coursera. So that's I guess the precursor. So now let's get into Rust. So why do I care about Rust, even though I've programmed in Python for 25 years, or give or take a few years? Why do I care about it? And what was it that really made me shift to Rust? So I would say the first thing that really got me interested was the Python packaging is really a problem for me, in that it's something where, as a pragmatist, I've been annoyed with Python packaging. I'm like, hey, what's going on here? Like, why is it so inefficient? What's the issue with different competing solutions, et cetera, et cetera? And I think in particular, the thing I'm most focused on is large language models and machine learning. And there's a bifurcation where there's the Python virtual environment, pip standard, and then there's Conda, and there's all these other tools. And a lot of the GPU based workflows would require Conda. And also Conda has a license. So it's a little bit like like Docker or some of these other companies where it's kind of free, but if an enterprise uses it, you have to pay a license fee. So just the whole thing just was distasteful to me. And so it made me look at alternatives. And about a year ago, I started to look at Go, Rust, etc., C#. Like, how do I still do machine learning, but actually start to migrate to different languages? Simultaneous to that, unless you've been asleep somewhere, you have been part of the generative AI craze. And so simultaneous to that, I started to look at generative AI and go like, hey, what is going on here? This is really cool. And to me, my research led me, because again, just telling you a little bit about my background, I've been making changes and shifting industries and changing techniques my entire life. I have no problem just abandoning everything I'm doing and switching to the new thing. So what I feel like is that Rust, because it's such a strict language, has a lot of advantages over Python in terms of what it can bring to the table in the world of generative AI. So that's kind of where I started to shift to Rust. And then at what we've seen in the last year is that there's actually so many amazing Rust-based solutions for large language models, and the framework that I'll show later in the day is a Rust Candle, and that you can just run one line and you can actually invoke a large language model. So that is really one of the things that I'm super excited about. And then in terms of performance, we know that Rust can be, 100 to 1,000 times better performance. And so if you look at use cases like, for example, AWS Lambda, I think a lot of people use Python for AWS Lambda, but I would challenge you to say, why are you using Python when AWS Lambda is a server-based solution, and Rust, you can write similar code, maybe it's 10%, 20% longer, but you could get 100 to 1,000 times better performance. Why wouldn't you shift over to something like Rust? So that's kind of the precursor here to some of the stuff that I'm gonna talk about. So now that I got the background out of the way, the first thing we need to do is actually show how to actually install Rust. So I'm gonna go ahead and share my screen here, and we can actually talk about it. So first up, what we need to do is figure out, what are the different places that we can actually install Rust. So I'm gonna go to a window that has a OmniGraffle in it. We'll go here, and we can actually make this a little bit bigger. And I think the thing to start with is that, where are the locations to install Rust? So first you can do local machine, and I can even do this. Local machine is one, and we can put this install Rust. We can go here. And a local machine, how would you do this? Well, the easiest way to do this is actually a tool called Rust Up, which I'll show in a second. Rust Up. So basically, you just do a one-line call, and it actually installs Rust. So there's almost nothing to do. In fact, it's amazingly awesome. The other one would be like a cloud-based environment. So I'm going to just build a thing here that says, cloud-based environments here. Now, there are lots of cloud-based environments, and I would say in terms of cloud-based environments, the two that are probably the best, in my opinion, for Rust, one of them would be GitHub Codespaces, and then the second one is going to be AWS Code Catalyst. Which is pretty cool as well. So let's type that in, AWS Code Catalyst. So in terms of like cloud-based environments, I think these are going to be the go-to solutions here for installing Rust. So and if we talk about the pros and cons here, let's actually just do like a pro con. We'll just say pro for local would be that you can actually use a powerful machine. So in this case, if you wanted to install Rust locally, there's a lot to like about it because of the fact that you actually don't need to worry about performance, because let's say you have, like in my case, I'm doing the live stream right now on a like a 24 core machine. You can use the whole thing and actually get a ton of performance out of Rust. So that would be the pro. If we go to the con would be that local environments are less like production, right? So that would be the downside here, would be that they're less like production. Now, if we go over to Codespaces, what would be the pro is that it would be very reproducible. So easy to reproduce, and actually very powerful. The only con I would say would be cost, right? Like if you have to pay for it yourself, that there's going to be a cost associated with it. The other one, Code Catalyst, I would say less easy to produce. So we'll say less reproducible, because GitHub, one of the advantages of GitHub is that they actually have this ability to like share your code spaces, which I'll show in a second. And then the cons for AWS would be, or actually, sorry, the con would be less reproducible. The pro would be that it's powerful and totally free for Gen AI. So that's the other piece of this, is that, in my opinion, you have to go beyond just the installation. I mean, this is nice, right? That you can go to this particular environment and run it locally, or you can go to cloud. But you also need to consider Gen AI. So the other part of it is that, what are we going to use for Gen AI? So let's actually put this as a block as well, which is that, what about Gen AI for Rust? What do we actually have? So we have GitHub Codespaces, or sorry, GitHub Copilot is one. We also have AWS Code Whisperer. Go here, Code Whisperer, and I would say these are the two top Gen AI solutions right now. Is these two, and let's actually talk about the pros and cons for Rust here. So I would say that the pro of the pro of GitHub Copilot is that it is first to market. Let's actually delete the con here too. So it's first to market. Good Rust support. The con is it costs money. Many lawsuits. So I actually, if people want to use Copilot, go for it. I've actually gone away from Copilot, and the reason I've gone away from it is that I don't agree with the business practices of OpenAI. That's just my ethical, viewpoint. And so I've shifted to Code Whisper. And so now, obviously, you can still use it for Rust. I'm just telling you what I'm personally doing. But in terms of Code Whisper, the thing that's interesting about Code Whisper is that the pro is that actually it is free, 100% free. So Code Whisper is free, as in beer. It also has the ability to do the multi-line support, so multi-line Rust support. And then the con would be, maybe like newer entrant. So entrant to space. So maybe it's that they're still kind of building stuff out in Code Whisper. So it's more of like an emerging tool. But I would say that the free and the multi-line Rust support for me makes actually the Code Whisper my choice. And I also say the pro is that, from what I gather, as well as like ethical data sourcing. So they actually have a lot of things like attribution, of where they got the code from, only trains on sources they disclose. And so I would say the con with this one as well is like dubious data sets, training data sets. We don't know. It looks like there could be some things in here that I don't like. So for me, I would say like that in terms of I would say that FUD, which is here, is fear, uncertainty, and doubt. This is really my issue with this particular solution, is that I have fear, I have uncertainty, and I actually have doubt about this particular solution. And so I'm actually going towards this one, and I'll make it like green here, is that I feel more confident with Code Whisper. I feel less confident with Copilot. So that's the choice that I made. And now let's I guess I can just save this thing, which so I can like keep it around and give people docs on it. We'll just call this install Rust. Now let's talk a little bit about after we install Rust as well, what the structure of a project should look like and what are some of the tools. So let's move on to another tool here. So I'm going to actually go to a new share and I'm going to call this one. So I'm going to stop this one. I'm going to share again and we'll go to this. Okay, so here we have a window that I'm going to build out about the project structure and why I like, we'll call this like Rust project structure. There we go. And I can just call this thing Rust project. So I would say, especially for Python people, that you should follow some kind of like reproducible structure beyond just Python, because you have so many holes essentially, because you need to get installation done, you need to lint your code, you need to test your code, etc. So I still use a similar style. This is just for me. What I would recommend is that I would actually think about building a makefile, and everyone has their own style. Like some people hate makefiles. I like makefiles because that means I can work across any project, any language. Like if you're switching languages too, like why not have a makefile? It makes like this idea that you're basically only going to use the tool that your language comes with, I think is a bad abstraction. I think it's good to have an abstraction. So when I do a Rust project, what I typically will do is I will have a install step. I will have a lint step. I'll have a format step. I will have a test step, and maybe I'll have a deploy step, right? And what's cool about this style is that you actually can, it really abstracts to most languages. And so if you're working with TypeScript, or if you're working with JavaScript, or if you're working with whatever, you're always going to have the same structure inside of a project. So for me, what this would mean is that I don't have to really think about anything. But in terms of the rest of the project, step one would be that you're going to run cargo. So you're going to say cargo new, and you're going to say like my proj, right? And so the cargo command, which we don't want this capital, it's just lowercase. The cargo command will actually create a new project. So we can make this like, I don't know, something like that. And so that's really step one. And then after that, you're going to get a structure inside. So let's look at the structure. What would it be? You would have basically a cargo.toml file, which I'll cover in a bit. You're also going to have a main.rs file inside of source. So at source main.rs. And so that's really the low level structure of what would be inside of a Rust project if you do cargo new project. A couple things to point out about this cargo.toml file is that whatever you name your project, you're going to have to actually, the namespace will inherit from the cargo command, right? So you need to be careful about, like, if you call your project my project, inside of here, my project will actually appear in the cargo file. So then if you later want to create a library, which I think is a good structure, just remember that you'll have to refer to it via lib.rs, right? So that's just something to be aware of, is that you need to actually use the namespace here like this. We'll actually do that, and we'll call that my proj there, right? So when you actually build out your logic, so the way I typically will make a project is I will put my logic here like this, and then I will do this will be essentially the controller, right? So basically this is where I would do, for example, web, CLI tool, etc. And then this would be where I would put in my functions, right? So we would do, basically the functions right here. So I think this is very important to be aware of, in that if you follow this structure, it's not going to be that much different from Python. And in fact, if you get into the habit of doing make, install, lint, format, test, etc., then it will also work well with generative AI. So I also want to mention the feedback loop. So the feedback loop that I would recommend is that you actually do something like this. You do basically step one would be that you create project. Let's make this a little bit smaller here. We can do here, step one, create project. Oh, that's fine, I guess. Create project, and then step two would be to build logic in lib.rs, and then step three would be to run it, and then you would maybe actually get suggestions from GenAI, and then Gene, we'll say from GenAI, and then also format your code after suggestion, and then also lint your code next, then run. So basically, you want to, in my opinion, get this kind of like feedback loop type thing going with your code, where you actually want to incorporate traditional software engineering best practices like installation, linting, formatting, testing, deploying, and you also want to implement a feedback loop where you're actually going through and using it back and forth. So why don't we actually just do that next? Is that I'm going to show how you can actually go into a local environment, create a new project, and then kind of get things cooking. So I think maybe first I'll start with a local Rust environment, just so that we see that first. So I'm going to go to my local environment and get a Visual Studio Code thing working. So I'm gonna get this thing cooking real quick. So we'll say maker sandbox, and we'll just say here. So I'm gonna share to a different screen here, and let's get a VS Code cooking. Here we go. So I got VS Code here, and what I'm going to do is that I'm going to open up a terminal, and I'm even going to CD into, let's say, like, let's actually go. Yeah, this is a good spot. Is I'm gonna go through and make a new Rust project. So how would I actually do that? Well, first you have to make sure that Rust is actually installed, right? And so we see that in fact the Rust is actually installed here because I did the rust up command. Once I've got that cooking, then all I need to do is actually type in cargo new, and let's just use my proj. Let's just say my proj, just like that. Now, the beauty of this, in my opinion, is it blows away Python because you don't ever have to worry about what virtual environment you're using or like what your structure of a project is that it is a very clear system that you're building. So if we go through here and I cd into my project right here, now take a look at this, is that I actually get that structure right here. In fact, what's nice is you can see there's a cargo file, and in this cargo file, it actually inherits that name. So my project. And then if I wanted to install a dependency, all I have to do is put in that dependency for me. So basically the tool is doing all of the work for me instead of me having to do all these like weird ad hoc solutions like you do with Python. I think this is a big advantage. The other thing to be aware of as well is that you don't want to check in the target directory because that's where all of the binary files are going to be kept. And so you do want to have a get ignore that says, hey, don't check in, target files, and it creates it for you, which is pretty cool. The other thing is if we look at the main.rs here, that it even gives you a hello world. And look, this is not too tricky, right? This looks pretty straightforward. So how would I actually run this? Once I'm inside again, if I do pwd, you can see I'm in this directory. I would just type in cargo run. We'll just type in cargo run. There we go. That's it. So it is not hard to write a Rust hello world. It's actually pretty straightforward. Now let's also talk about the other parts that I mentioned, which is that I typically would want to build out a makefile. And so I can probably grab one from some other project that I have here. Like, I don't know, maybe this is one, rddupe. So I'll just say cp rddupe makefile. And then let's look at what I would put inside of that makefile. So if we go back here to my proj, and we look at this makefile, look at some of the things that I typically do. I mean, and you can tweak it based on whatever it is that you want to do. But basically, we could do a format check, we could do linting, etc. In this case, it could do build releases. We could run the program. But I actually like to have a makefile in general, just because it kind of makes things a little bit simpler to run. Now, this one's a little bit complex. I'm going to grab a slightly simpler one here real quick, and I'll paste it in. That is a little more like user friendly here. So let's go to Rust, and I'm going to grab a new one here. And I'm gonna go to like a little bit simpler makefile. Like, let's grab this one. This will be a little easier to understand. So if we just go through here, there we go. So this I think is what I would call the hello world kind of makefile. Is let's format our code, let's lint our code, let's test our code, let's run, and even run them all together. If you're a Python programmer, in my opinion, if you're not doing something like this, I think there's also a problem, because these are essential components of software engineering best practices. You can't not do these things. You must do these things in order to be a successful software engineer. So let's actually try them out, right? So if I go here and I take in make format, there we go. I format my code. If I type in make lint, it lints my code. If I type in make test, well, there won't be any tests because we didn't build any. And if I type in make run, right, I mean, I could do cargo run myself, or I do make all. I think this style is a good style because later when you go to production or you go to a build system, you can actually have, let's say, GitHub Actions, AWS Code Build, Jenkins, or whatever. It can actually run this. So the only other thing that we're missing here is that, remember I talked about Gen AI tools. So see this right here, this Code Whisperer. This is the one I would personally recommend. Is that it's, first of all, it's free. It's pretty good as well. How would I install this? We'll go to extensions, and if you type in AWS toolkit, check this out. We go here. If you just install the AWS toolkit for free, you get access to Amazon Code Whisperer, and you just have to create an account with AWS, and you'll be able to actually toggle this on. So how would I toggle this off and on? I go here, the extension, see where it says Code Whisper, see what it's doing right here, pause auto suggestion. So if I want to run it, this just has to be turned on. Now, it also has some really cool stuff too, which is it can even do security scans on your code as well. So I think it's a really cool tool to be aware of. I think maybe the last thing I can show you is let's actually now use it, right? So if we go to my project here, I think an easy one to show that you can actually play around with would be a calculator. And a lot of people are talking about prompt engineering, which is basically telling the generative AI tool what it is you're going to build. And I would agree with this. This is very important. So we should always set the context first. So in Rust, a multi-line comment is like this. And so what we can do here is we can just say what we're going to build. We'll say like, this is a simple add and subtract program. And so now the prompt has some idea of what it is I'm going to build, and I'm going to get more and more suggestions in the future. So what could I do next? Well, we need to be able to write a function in Rust. Now we can even get a hint here. It doesn't look that much different than Python. It's a little bit uglier, because the syntax is uglier, but it doesn't mean it's that much harder. We just need to do an fin. And in fact, the generative AI tool basically tells us what to do. So it's going to give us a completion suggestion. I just tab it. And the only thing different really than Python is that you have to declare types. So in this case, we are going to have to declare that it's an I32 type, right? We have two types here. Now the benefit, and it took me a while to really completely agree with this, is that a lot of times in Python you're like, oh, types suck, but really you do want types because it's going to make your code more robust, especially if generative AI builds the types for you. Why would you not want the types, right? They're going to make your code faster. They're going to make it more reliable. And so all we need to do is basically return A and B. So if we go tab here, look at this. We've got that. Now, I'll show you another thing that happens here is that notice that automatically the Rust ecosystem here is going to tell us lots of really good warnings. So it's going to say, hey, you can't do this. Add is never used. In fact, let's use our make file here and let's actually play around with this. So if I go here and I say make format, right? I would say that's the first thing I would do after I get a suggestion from the tool here, is I would say make format, and then I would say make lint. And it's going to tell us that we haven't used the add function. I mean, this is great, right? This is basically a really productive workflow here. That's not too bad. Is I just say generative AI, I do make format, then I do make lint. Now, how would we actually use this? Pretty easy. I would just call it as a function. So we can just say let result. I mean, you could do the generative AI, or if you want to get practice typing it, right? You just say let result. Now let's just say in this case, I want to do 5 and 8. And then the only other thing you have to remember in Rust is that you have to do semicolons, which to me is not a big deal. And then finally, we need to put it inside of here, right? The result. Because look, it's again telling us, hey, if you don't want to use it, you could do this, which is kind of silly because we want the result. But in this case, I do want the result. So in this case, all I need to do is just say, hey, let's pass this variable inside of here. And again, because we have a Gen AI tool, it should be pretty good at giving us a suggestion, which is, yeah, there we go. That looks good. And in fact, let's add that semicolon, and let's again say make format, make lint, and then we can do cargo run or make run, whatever. Cargo run, there we go, 13. So not too bad to program in Rust. So this is a good spot. I'm going to keep with this pace of every 15 minutes to the top of the hour. I'll take a 15-minute break. And so I'll just mute and come back at the top of the hour, and we'll just keep going. All right. So just hang tight. I'll see you in 15 minutes. We'll say I'll answer questions. Okay, so I see some questions here. Let's go ahead and answer these questions. So one question is, does Code Whisper only work with Cloud9? No. So that's a good question, Art, is that Code Whisper works with basically all major tools. So it works with Visual Studio Code, it works with AWS Cloud9, it works with AWS Code Catalyst, it works with IntelliJ, it works with GitHub Codespaces, which I'm going to show in a second. So basically, you can think of AWS Code Whisper as a direct free competitor to GitHub Copilot. Okay, another one is we could also use dev containers as an installation solution. Correct. In fact, that's what I'm going to show next is how to use dev containers. Yeah, Jason, I agree with you that it is actually a true language because you can do everything. And then another question here was, so there's no concept of virtual environment like in Python. Correct. Like every cargo project is a self-contained environment with no dependencies. I think Python should do this, to be totally honest. It's a very superior workflow. And then in terms of question here, is the makefile basically a sort of pre-commit file? No, it's I mean, I guess in the sense of you would want to do those actions before you commit. In that sense, yes. I just think of it as the software development best practices that you should always do, and that if you make a make file, you can also easily put that into the build system, right? Like you could do the exact same steps you're doing locally into the build system. And then in terms of Python, yeah, so we're not actually doing anything in Python yet. Great questions. Okay, so let's keep moving here. What I'm going to cover next, because I showed how to do Visual Studio Code local, let's go to the web now, and actually let's get into um, some of the things that you can do with web-based environments for Rust. So I'm going to share my screen here, and we can go from there. So what's I definitely like GitHub Codespaces, but like I mentioned before, I've drifted to Code Whisper, and so you don't have to use everything from GitHub at the same time. You can use some of GitHub. You don't have to use all of GitHub. So what I'm going to do is I'm going to show you that I have an organization here that I do a lot of teaching out of. And if I say new, this is one of the things that's pretty cool about GitHub is that you can use a repository template, and you can even import repositories, etc. In my case, I already have a Rust template that I'm going to show you how to use. And in this case, we can see, look, Rust new project template. So you can actually, if you wanted to get a dev container that's set up the way I've set up this stuff earlier, you can just go to that repo and import it. If we select this, I can just say like, live stream Rust or something like that, workshop, and maybe even put today's date or something like 10/12. Okay, so this is a demo repo for live streaming Rust, and that's it. I just have to inherit from it. Now I'm going to change this though to another organization so that I can show you how to use some of the compute. Now, as I mentioned earlier, if you have a super powerful machine, like a 24 core machine that's, I don't know, like a Mac Ultra Studio, which I have, then I like using it. But you also can use the web-based tools as well. So in order to use this, what I'm going to do is I'm going to click on code, and I'm going to click on this code space repository configuration here. I'm going to click on it, and I'm going to say new with options. And now let's look at some of the things that we can do. It even tells us the dev container configuration. So I'm going to use that Rust configuration here. And I'm also going to use a 16 core machine. Now you can do GPU as well, which is actually a really cool feature of Rust, is it has amazing GPU support. I'll show that, but let's go ahead and do this, which is 16 core. And then I'm going to go ahead and say create code space. One of the things that we can do as well is look at logs when you're using code spaces. So I think code spaces is a great tool, especially if you want to do like demos and you want to share things with other people. I think it's a nice part of your toolkit. I don't agree with GitHub on everything. I like a lot of what GitHub makes, but hey, it's a free world, right? I can do some things I like and some things I don't like. I like Code Whisper better than I like Copilot, right? So I can use Code Whisper though with the rest of GitHub. In fact, that's exactly what I'm going to show you, is that you're not locked in to one particular tool or not. In fact, I would even question, why are you pushing this one tool so much? Like, what's wrong with it? It's like, why are you selling me this 1984 Ford Mustang that smokes? Is there something that I don't know? Okay, so let's get into the configuration here and look at this. So if we click on this, I can go to themes and I can go to color theme. I like personally the colorblind beta. I just like how it pops, and you can go up and down. You can make it bigger, smaller. The part that's the dev container, let's just briefly talk about that. So what did I do is here, see this? I'm saying from MCR Microsoft dev containers use this Rust dev container, and then it just does this update. What's really cool about it is it basically is a fresh environment that I don't have to worry about weird stuff being installed inside of it. And then inside of the dev container, one of the things you can do is you can tweak it and make it do whatever you want. So this is basically like a default Rust dev container, but you can even put in different extensions. So this is what I was going to say, is that, for example, let's say like, hey, GitHub Copilot, I'm just not that into you, right? We want to have a breakup. I have a new tool. So I'm just going to do that. And in fact, I'm going to go ahead and check this in. If I say git status, and I can say git add.dev container, and you could even customize it, right? Say like adding new setup for extensions, right? There we go. And we can just even push that. Now, in order to install Code Whisper, I think many people are interested in this. If you just click on this, what I can do is I can see all of the extensions in here. So I'm going to go here and I'm going to say uninstall, right? And we could just do a reload. Let's try that out. And obviously it's not going to show up here anymore. And then if I also want to do Code Whisper, what we can do is we can say Code Whisper, or actually AWS Toolkit. Click on that. And look, installs Code Whisper, Code Catalyst, and support for Lambda. I think this is really a stealth tool that not a lot of people know about. And as I mentioned before, this is free as in beer. So why would I pay for something when I can get something that's free that looks a less sketchy, in my opinion? So I'm going to go ahead and click this thing and install it. And then if we go to Code Whisper, what's going to happen is as I click on this, notice what it does. It says you have to have an AWS Builder ID. So it's free. Just create an AWS account and do this. Since I already have one, I'm just going to click on sign in. It's going to go to this authorization request. It's going to say, yeah, I'm okay with that. And then that's it. Now I can use Code Whisper. It says you can always return to learn about it. So now if we go back here to extensions, you'll see that I've got AWS Toolkit installed. And what we can do as well is actually look down here. Look, see how it's highlighted? We have Code Whisper. It's actually installed. And if I click on the left button right here, notice Code Whisper. There we go. Pause, auto suggestion. So I think a lot of people are confused about the fact that that Code Whisper can be used with GitHub Code Spaces. There's no reason you can't use other generative AI tools. Just because you're using GitHub doesn't mean you need to use GitHub Copilot. In fact, again, AWS Code Whisper is free. So let's do the same thing. Let's actually, kind of kick the tires here and get stuff working. So what I would do first in a new project is I would go kind of clean things up a little bit, just say like, hello world, Rust code whisperer, right? And then I would do cargo new. So we'll just say cargo new, like hello, right? And we can see hello is created right there. So in my opinion, very, very clean kind of environment here to work with it. And I think I did make a makefile here that's kind of close to probably what we would want. And so I could even copy that makefile inside. We could say, sure, let's install this makefile extension as well. So once you install an extension in Visual Studio Code, what you would do is go back here. If you want to save it into your code space, is you would actually right click on it and say add to dev container JSON. And same with this, right click, add to dev container JSON. And what it will do is it will actually add it to this dev container JSON file. See, there we go. So now we actually could check that in, and other people could completely reproduce everything that we're doing. So if we just say git status, we'll see that those files are changed. Now, the other thing too is always to make sure that in my case that I want to make sure that we have a git ignore inside of the hello project. So let's go ahead and let's actually add a git ignore target for hello as well. So let's just say like hello target. There you go. How about that? And so if I go ahead and do cd into the hello, and we type in cargo run, and I do git status, we should see hello is checked in. And if I say git add.get dev container, git add.get ignore, and I say git add readme and git add hello, that way I don't, if I do a git status, we're not going to check in the target, right? We don't want that. We don't want to check in binaries into GitHub. It's annoying. Sometimes I make the mistake, and then I just do git commit new changes for demo, and then I git push. So that's typically what I would do to kind of set things up here and get everything cooking. And again, make it reproducible so that another person on my team could actually just use this GitHub code spaces here and get all of the extensions that I want for them. And so I think GitHub Codespace is a really cool technology that not enough people are using. And again, it's flexible. You don't have to actually use Copilot. So the next thing I'm going to do is let's keep doing what I was doing before, which again, here we see like we want to maybe reproduce that workflow. So I'm going to copy the makefile here to hello, and then I'm going to just take a look at it. This looks good here, right? If I cd into hello and I type in make format, for example, it would format our hello code. So we got all that working. So now let's go ahead and reproduce what I did before. Let's test that Copilot works. We can say add and subtract script. Perfect. And let's go ahead and do a function. So it's always a good idea to guide the Gen AI tool again. So you could even guide it like this. You could say like add function, right? And so a Rust one-line comment is like that. If we do that, there we go, right? It actually writes it for us. So even if you're not a Rust expert, that's actually one way to get started with Rust, is to do multi-line comment at the beginning, and then to do a single line comment for functions, and basically the code can write itself. So remember, this is going to be add and subtract script. So we could do the same thing, subtract function. There we go. It creates a subtract. And again, you can see the logic is the syntax is fn, you have the function name, you have the arguments with the types. This is going to be the return type, and then it's going to be the body, and the body implicitly returns in the Rust language. So next step here, we can actually, basically put it all together. So I'm going to say, we can say for here, let x equal 2 there, and we can say let y equal 3. And what we could do is we could say let sum equal 2, and we could add those together, and then we could say let difference is equal to subtract, right? So that way we actually were able to add things together and subtract them, and then right here we could say basically print out the results of both the add and subtract functions, right? So again, I'm kind of guiding my Gen AI tool to help me out here, and we could actually, I'm pretty sure it's going to be smart enough to know how to help me out. So I might have to help it a little bit. Print ln. There we go. Yep, I helped it a little bit. So I think this is the world we're going to live in, is that, why wouldn't you let a tool write boilerplate code for us? Because I know what it is I'm building, but the tool is faster than I could probably even type it. So why wouldn't I just let it type it in many scenarios? Again, I'm still the architect. I'm still building this. So now if we go through and we say make format, it kind of cleans things up a little bit. If we type in make lint, right, we can lint it. Looks good. That's what I typically would do, is I would do Gen AI, make format, make lint, and then we just say, yeah, cargo run. Let's run it. There we go. Got it. We're all good to go. So we got another environment taken care of. So let's check all this in. Adding code for demo. So what else can we do though? So we know that there's actually another tool that we could do called Code Catalyst, which is a very new tool. Let's actually dive into that thing. So now I'm going to dive into this tool called Amazon Code Catalyst next. If we go to Code Catalyst, it's only available in 2 regions right now. I'm going to go to Oregon, and you can see here that you can create these spaces here. In this case, I already have a space set up, and then I could go to the Code Catalyst window. Let's go ahead and wait for this thing to log in. And then inside of here, you have projects that are created. So I have a project here that I created. And what you can see here is that if I wanted to, I can actually create dev environments that work with Visual Studio Code. The other one I could do, if we go back to this other window here, is I also can work inside of the browser. And if we go to this, you can see that I've already got one set up in the browser. So let's go ahead and look at what a browser-based dev environment would look like for Rust. All right, it's still waiting here. It'll take just a second to set this thing up. Okay, So you can see that this AWS environment here is actually a competing solution to Visual Studio Code. I would say it's okay, this environment. I personally like Visual Studio Code better, but especially if you're working with AWS, I think it's a nice tool to be aware of here. And so if we look at the structure here, you can see here that I've got some code right here. And if I wanted to do a PWD, we can see I'm inside of a project directory. And if I type in which Rust, Rust C, you can see that I've got Rust installed here. But this is probably a good idea to do something like this, which is let's just briefly talk about Rust up here. If I go here and I say Rust up, it all I need to do to install Rust on a new environment, and which is what I did here, is I actually just typed in this command, curl, and it runs this Rust up command. Let's just see how it would work. It says, okay, how do I install Rust up? Proceed with installation, default. There we go. And it's going to go through here. It's going to download it. That's another really huge advantage of Rust, is that you can basically install it on any machine very easily. And in fact, in this particular location here, I just go ahead and do this, and then that's it. That's all you need to do to get it installed inside of the Cloud9 environment. Now, as well, remember it has the toolkit. So if I want to do Code Whisper, what I'm going to do, I'm going to actually copy code and proceed, copy this code, submit it, allow it, and we can now close this window. So now I also have access to Code Whisper. There we go, connected. And so what I could do is do the same thing. I could just say cargo new, and we could just call this hello. There we go. I could cd into hello. And if we look at this hello directory, that I could do similar things like what I did before inside of this environment. Notice that we've got a main here, and I could do the same thing. I could do, multi-line comments and say that, this is an add function, right? And it could help me out. There we go. Right. So this is also a legitimate environment. I find that the Visual Studio Code integration is definitely a little bit smoother. But what's nice about this is that it's just yet another solution here for AWS. So I won't go too much into this because it's not as, I would say, compelling. I do want to talk about environments. One more thing really quick about environments, though, inside of AWS. If we just close this one, we close this one, and we close this one. If we go over to EC2 here, and we say my EC2 environment, another thing people are not actually aware of is that one of the things that you may want to do is code against a GPU-based environment. And so let's go ahead and look at my instances here. And if we go to North Virginia, what you'll see is that I actually have an instance that is a GPU instance. And in fact, we can see this because you can see that it's a Ubuntu instance. I'm using an AMI called Deep Learning Base GPU AMI. Now, I think this is something that a lot of like sysadmin people, DevOps people should be really aware of, is that there's an emerging large language model operations kind of field that's opening up, where people are going to need to actually run their own GPUs. And so in this case, again, look, we're running the deep learning GPU here. And in fact, for me to actually get this working, I can actually do it even inside of the browser. So if I go here and I say start instance, let's take a look at this. And I go back to instance. It's going to take a second, and I can actually just program against it inside of AWS itself. So I can go here, and I can actually go to the serial console here. Actually, let's see. I think I can just go to instance connect here, right there. There we go. Instance connect. And so once this thing spins up, I can actually do Rust programming in a shell-based environment as well. And I think it'll just take a second to wake up. We just have to wait for this thing to, oh, it's running. Okay. So I think, yeah, there we go. So now we're in this environment. Now, GPU is a little bit different of an environment than a CPU environment because of the fact that you're going to be running workloads that are designed to really capture the power of the GPU. And so if we type in NVIDIA SMI L1, what this will show us is that we can do like a loop that actually shows the CUDA version here and how much GPU is being utilized. So you may be asking yourself, why do I care about this? Well, the whole world, or we can actually just kill this, the whole world cares about large language models right now. And in fact, they're going to run a lot better if they have a GPU and they have the CUDA driver installed. And so in this particular machine here, what I can do is I can actually use this as a software development environment. So let me show you why Rust comes into play. You might go like, well, what does this have to do with Rust? Well, if we go here and I go into Candle, if we say get remote -v, this is actually my origin here is GitHub Candle. And let's actually just go to GitHub Candle, GitHub Candle Rust. And if we look at this thing, if we check this out here, like, what is this? What do I care about this? Well, the reason you should care about this is that basically you can run any large language model with just one line of code, right? Like you can see all the different cool, models here, StarCoder, you can do this Mistral, Falcon, etc. All these you actually can run locally here. So if we look at StarCoder, for example, take this out, look at this. I can actually run a StarCoder example. So I'm actually gonna do this. So let's go to our environment here and let's just do a git pull to get the latest, because they're actively making this thing better. Like it's just constantly changing stuff. And then if we go and we run that command, you can see what it's going to do. It's going to say cargo run -s example, big code, release, prompt, and let's go ahead and run that. And let's see what it does. So basically we can have our own open source large language model tool that actually can be using libraries that other people have written here, so that we actually can run it using this GPU environment. So let's go ahead and do this and get this thing cooking. What I like about this kind of workflow as well is that even if you're not like a hardcore developer, you can still take advantage of large language models by just running this one line because of the ability to leverage the Cargo ecosystem. So you can run tons and tons and tons of large language models here in a GPU-based environment. And once this thing works, the other thing I'm going to show is that you also can connect your local Visual Studio Code into this particular environment. There we go, running on CPU to run on GPU, build with features. So it's now doing a CPU-based loop. And so you'll see here, this is going to be like super, super slow because it's only running a CPU. And we know that inference for large language models on a CPU are not great right now. I'm curious in the future how fast they'll get, but for now, the CPUs can be very, very slow. But you can see here that it's actually building an example here, a factorial function in Rust, and it's working. It's working. Give it some time here. There we go. Right. So you see, it's basically doing its work, but it's so slow that I'm actually going to just say, like, I don't want to wait. I'm going to go here and I'm going to do, notice how it said do -s features CUDA. This is, again, one of the really cool things about Rust is that we can just go here and we can do the flag -s features CUDA. So this says, look, why don't we just use the CUDA drivers? Let's use the GPU here. And this should be way, way faster to generate some Rust code for us. Okay, it's building. Here's the big code example. All right. And you'll see here it's going to be pretty fast. There we go. Look at that. So look at this. I mean, isn't this pretty crazy? Is like you not only do you not have to use somebody's proprietary tool, but you don't even need to use. You can run it for free, right? Like you can have your own coding assistant again using Rust. That's what's so powerful about it. Now let me show you a little trick here, though. See what it's doing is we're compiling every time. Why would we do that, right? So I'm going to do a little trick, which is I do Control A hashtag. I'm going to clear the screen here to make it go up to the top. And what I'm going to do is I'm actually going to cd into the target directory. So you see how there's all this stuff here. We're going to go to target where the binary is. Now check this out. If we go to this environment here, yes, Jeremy, it's recorded. So basically inside of this binary, if we go into debug and we go into examples here, check this out. All I have to do is go to big code. Or I just have to do the same command I did before, right? See this? I just go like that. And do big code, just like that. Check this out. We don't need features because, in fact, we don't need anything. We just need this. We just need big code. Boom. We have your own local large language model. To me, I think this is the stuff that kind of sysadmin, DevOps kind of people should be really paying attention to is like, wait a second, I can run free large language models that give me all of the things that people are paying all this money for, $10 a month for. Why wouldn't I just use this? And we know that there's going to be intense competition in the large language model space. So why wouldn't I be, basically pumping, forward with this kind of skill? So this is, I think, a very, very cool skill. Now, let me show you the last thing I'm going to show is that this is in the browser, but you actually can develop against a GPU instance using local Visual Studio Code. And so now you can use a GPU-based development environment with Rust. So how would we do this? Let's go here and actually let's go to this instance and notice that we have the public IP address here. If I want to connect to it and I want to connect via the SSH client, it's basically going to say like, here's my command here to do this. So I can just copy this. Then what I'm going to do is I'm going to go to my local environment here with Visual Studio Code, and I'm going to set this up. So I'm going to go back to Visual Studio Code here, and what I'm going to do is I'm going to do this thing called add new SSH host. Check this out. And if I paste this in, look at this. User, I think it's this one. Host added, connect, and we want to continue. Couldn't. So I just have to make sure that I have the SSH key set up here, and I may not have it handy, but basically you can, just to make a long story short, is that that's probably easier just to show that is that all you have to do is you have to download the SSH key, which because I'm in a live demo, I won't do it. Download the SSH key, and then you just add new SSH host, and then you can actually work remote. And so that's a really awesome workflow. In fact, I could actually show how to do that. that might be a nice thing to show real quick. So let's actually go through there, and let's go back to our web browser real quick and go to connect to instance. So let's just spin up a demo instance here. Let's just say launch instance, and I don't have to. I mean, I guess I could try to do a GPU. Let's just say like GPU Rust, for example. And then if we look at Ubuntu, let's look at the architecture. Let's look at the type here. I want to do a G5. Let's just pick like the cheapest G5 there is, which is like this one. Is like a really cheap GPU based G5. So let's make a new key pair real quick, and let's just call this like demo 12 10 demo 1012, and let's create the key pair. And then we'll let people SSH into it. And I need to make sure that I'm using Ubuntu Deep Learning Base. There we go, that one right there, Deep Learning Base GPU is all I need. I don't need PyTorch because Rust doesn't need that. And then I should be able to just launch this thing, and this should just take just a second. There we go. It looks like it was created. If I then refresh here, whoa, that was quick actually. GPU Rust. If I go to connect here, we can basically just change the path here, which would be my downloads. So I'm gonna go back to VS Code here, and I'm gonna present. I'm going to go to share screen and go to VS Code. Here we go. Let's go here, and let's actually remote add new host. But I'm going to change this to be the path where the new file is, which would be it's going to be, I believe, in my downloads. So let's double check here. So I believe it's going to be ls demo 10. There we go. So it's going to be tilde downloads there. I think that's it. That should work. Enter. And we can update this config file, connect, and we want to continue. Oh, because I need to do the chmod. I always mess that up. Here we go. Let's chmod it. Let's go back to this and retry. Okay, so now I'm going to slightly change I'm going to change to a different one, which is the one that's actually, because it spawns like another Visual Studio Code. So check this out. So is this cool or what? Is that now I have Visual Studio Code GPU. And in fact, if I go to, look at this, we see it's all running here. And if I type in uname -a, look at this, we're running a GPU. In fact, if I want to do GPU, I just type in NVIDIA SMI, already installed for us. So if you want to be a large language model developer or sysadmin or MLOps person, there you go. You're all set. Now, we're missing one of the pieces though, right? Because if I do Rust is not installed. Easy to do though, right? Now we actually have an excuse to do Rust up. So let's do it. Let's go to Rust up here and let's just see how easy it is. That's it. You just run Rust up command and now you got Rust. I think this is easier than a lot of languages because You just spawn a GPU instance that's got CUDA installed already for you. You do the rest up command, and you're good to go. And then if we go through here, we can actually source the cargo environment like that. And then if you wanted to do Rust candle, for example, I'm going to Hugging Face candle here. If I wanted to actually download this, I would just do something like this, git clone, grab it. And then again, I could also just go to the local file system, open folder, candle, okay. And it's going to show me that I actually have access to basically all of the file system on this remote machine. And in fact, Rust is there, right? It's on an Ubuntu machine. And then if I look at the README file, I could also do a hello world here as well, right? So I could just go through here and just say like, okay, what do we want to do? Let's get something running. So again, I'll do like a, I'll do one of the examples real quick, which is that, how about we'll do, let's do the star coder again example, which is I'll run this, right? And you can see that it's actually compiling all that stuff. But the one difference here is that I'm going to add the flag that we know we want to do -s features CUDA, right? Like that. There we go. Whoops. -s features. Oh, -s features. Let me double check what the big code example, big code. Let's run this one more time here, and let's just see what the output is for the compilation. So it's going to be pretty quick, and we also can open up new shells now that we have another machine. So I can do htop, for example. Here, I could also have another terminal that does NVIDIA SMI L1 or L1, right? Right, and so I could even pop this into here, right? So I could basically, while it's compiling, I could look at the GPU, for example. So really, you have a whole development environment here that's all set up for you by using the remote GPU. So I think this is another strength here for building out your local development environment, is to not only pick, let's say, a Mac OS 10 or whatever machine. You can actually spin up a GPU on EC2, do the remote SSH connection, and then compile the software that way. So we'll just give this just a second here and let this thing compile. So obviously the bigger the GPU, the faster the compilation would be as well. So you could obviously get a monster machine, right? And if we go here, we can see that, look at this. That's the cool thing about Rust is, look at it. It just saturates all the cores when it compiles, which I think is pretty cool. It's got a little bit more left here to compile. So this is, I think, an emerging way to develop, is that a lot of Mac developers don't have a GPU, and that's an NVIDIA GPU. So why wouldn't you just do a remote SSH connection to a machine, and then now you're a GPU developer that can actually code with the latest large language models. And in fact, you could even store the large language models on the machine. You could store them in, let's say, Amazon EFS. You could put them in S3, et cetera, et cetera. The only limitation is going to be how big of a machine you can work with. And again, I mean, I think you could make the case for maybe you want to get a super big CPU and GPU to develop against, because Rust can take advantage of all of the cores when it's compiling. So why not? Why not get the biggest machine possible when you're doing development, and then just shut it down when you're done, and you can be a LLM ops developer. So it looks like it's almost done here, finishing up the compilation. You can see where it is with Rust. It's 341 steps out of 391. All right, 2 more steps left. It looks like it's doing the final step here. There we go. It looks like, I don't know, some issue with it, but basically, we can develop against a local GPU as well with GitHub. So let's take another 15-minute break, and what I'm going to do when we get back is actually get into libraries in Rust. And so what I'll do here is I will share a timer, which probably seems like a good way to cover this. Is let's just start this timer, and I'll be back in 15 minutes. All right, see you in a second. All right, so we're back here from the break, and we'll actually get into. There we go. I do refresh there for a second. So basically, coming back from the, there we go. Yeah, I was having some kind of weird feedback. Not sure what was going on there, but I don't see it anymore. All right. Hmm. Mute my- There we go. Yeah, for whatever reason, StreamYard was freaking out there for a second. Okay, let's just keep moving here. So, question about let's get to that next here. So, I think the easiest way to cover that concept is why reinvent the wheel. Let's just go through the docs, right? So, I'm going to actually share my screen here and build this out and present this. Go to what is ownership. All right, so let's dive into the official Rust documentation here for ownership, and we can see that basically, in fact, I think you have like this little wizard that can highlight things. I'll put that there as well. And if I go to uh, highlight, well, I don't know where it is, but I used to have this thing that I could highlight things, but I don't really need it. So ownership is basically a set of rules for how Rust is going to manage member safety. And so, really, if we scroll down here, this is what we care about: is that every value in Rust has an owner. There can only be one owner at a time, and when the owner goes out of scope, the value will be dropped. And so, a good example would be to look at the basic syntax here. So we have, that s is equal to hello, and in this case, the variable refers to a string literal. But look, this is not valid because it's not declared. It's valid from this point forward, and then you can do stuff with it. And so the scope is a big part of this. Now, if we look at another example here, where we say, look, here's a string, uh, and we can actually mutate the string. We'll say, let's go ahead and say mute. This is something from Python that many people will not be familiar with. Is that in Python everything's mutable, but in Rust everything has to actually you have to explicitly say it's mutable. So in this case, look, you have to say let mute right here. Then you can actually append things to it. So this is a safety feature, right? Because in general, it's a better practice to have a language that can make it explicit or implicit immutability. And then in terms of memory allocation as well, uh, Rust takes a different path here, is that memory is automatically returned once the variable that owns it goes out of scope. So in this case, the scope is now over right here, so S is no longer valid. Which is nice, is that that actually solves the memory deallocation problem for you. And then also the moving is something you'll see a lot that happens where, let's say we again have let x and x is equal to 5, let y is equal to x. That the issue is that you can probably guess that bind the value to x and make a copy of it. Now you have two variables. This is what's happening. And if we look at this from a string version as well, you can see that here we go. Let's make a copy of it. Um, but if we keep scrolling down here, one of the things that happens if you do this if we say let s is equal to 1, or S1 is equal to string, and make a copy of it, you're going to get an error because Rust is going to prevent you from using the invalidated reference, right? Because again, it goes out of scope. And so that's just something you'll see a lot, is like value was borrowed here after the move. And so this would be the difference between a shallow copy and a deep copy. So what you would do instead here is, if you did really need to do that, which is kind of a weird pattern, you would actually have to clone it. So that's something you'll see quite a bit, and it's kind of annoying to run into, but it does have a lot of good safety mechanisms associated with it. And then again, here we can see ownership and functions, is that S comes into scope here. This moves into the function. Uh, X comes into scope. This moves into the function. And here it goes out of scope. And so once you know those basic patterns here, then that's really the thing to know about borrowing, right? So it's actually not that horrible. Immutability, and then making sure you understand when something goes in and out of scope, and that's it. That's basically borrowing. All right, let's talk about libraries now as well. So if we go to crates, um, one of the things that is different about Python versus Rust is that they have a different packaging system. So as I showed earlier, the packaging is actually very awesome with crates here. And so in this particular scenario here, all we have to do to get this thing cooking is that we can actually uh, you know, look at this. We can see there's crates, there's most downloaded, there's just updated. So we actually have all of these different ways of dealing with this, which is like a newer kind of a packaging system. So what I typically do is I'll look at like some topic, like I don't know, like chameleon tool or something, and it'll actually show me the relevance. And I like to look at the downloads because I think it's a reasonable way to look at things. You can say like all-time downloads, for example, and you can take a look at it. And so there's a lot to be said here for, just being able to use these different search tools to actually find out what are the libraries that you should be using. So for example, the command line parser here, clap, which is the one I like to use, you can see here the downloads are pretty ridiculous, right? There's a lot of downloads. And so looks like it's probably a good library to use. That's typically what I do when I want to make actual suggestions here. So with that being said, let's go ahead and start to use libraries. So I think the easiest way to do this would be to use the code spaces environment. I'm going to close the rest of them. I think I could shut this instance down real quick, so that I'll shut them both down actually. I'll just say instance settings, instance state, stop. There we go. And then we'll go here, close this one up, and then let's go to the code space, which if I refresh it, it should pop up here. There we go. There's our code space. So the nice thing about code spaces as a demo is that it's basically in the web browser, so you don't have to actually do as much work. It actually is all set up for you. So this would be a great place to start playing around with Rust libraries, is to use this particular environment. So what I would recommend to start off with is we can again use that same structure here. Is we can actually do cargo new, and I think a fun one to play around with is Marco Polo. Let's just go ahead and make a new Marco Polo function here, and we'll go ahead and do that. There we go, Marco Polo. And then if I cd into this, and I cd into Marco Polo, what we can do here is actually play around with libraries. So in order to do this, we're going to need to go into the dependencies here and put in our dependency. Now, one of the ways to get the latest library would be to go back to cargo here, and if we click on the documentation, you can see like command line parser for Rust, and it shows you that you can actually just click this and you can add it, or you can also do cargo add clap. Now, notice that you can do this declaratively or procedurally. So if we look at examples here, you can see there's like derive is one of the examples here. So if you wanted to do a derive example, the way that you would do that is you would, I think I have an example actually in another repo I'll pull up, which is if we go here and I go to REST data engineering, I'm going to grab a command line tool that I have that I've already done. So see how it works right here like this. If we go back here and we throw it in, this will get the version and it will show us the features that we want. Now notice that it'll also do an automatic version check for us here. So this is pretty cool because look, we can see that there's 446. So yeah, why not? Why wouldn't I just run the latest version? And look, if I do too new, look, it'll say you're actually, that doesn't exist. And so there we go. We have the latest version. So that's all we have to do. I also like to copy the makefile in. So if I go through here and I say CP here and I do the makefile, we have a makefile. And then it's up to us to decide, do we want to start to build out some logic versus just using the main? So I would say once you start to get into libraries, why not? Like, why not just start, getting into, building things up here. And so that's what I'm going to try to do next is to actually try that out. So let's actually go back again to a command line tool structure of another project. Notice how I do this. I put it into the lib. So if we go back here, what I would do is you would say touch source lib.rs like that. And then we could refresh this. And in here is where I would put my logic. So again, we can use generative AI to help us out. So I would go here and just say, this is library code that is a Marco Polo function, like that. And now all I need to do is basically build a Marco Polo function. And so I can say pub fn. Now notice why I did pub here is that I want to expose this function to the main. So if I just do this, that won't work because it will only be available in this file. So I have to say pub at the beginning here. And then if we do Marco Polo, yeah, that looks pretty good. Although we don't want a number. I actually want to do something a little bit different. So I'll even put a comment and say a Marco Polo function that takes that looks for Marco and returns Polo string or no, if no match, if not a match, right? So like, again, the more I can guide it, the more I'm going to get help with building this thing out. And so we'll again kind of go back here, pub fn Marco Polo. So what's cool about if you're generating really descriptive documentation, which you should be doing anyway for your code, you're going to get better feedback from the generative AI tool, in this case, Code Whisperer. And so we can see here that, let's take a look at what it does. So first up, we have pub exported to the main. We have function here next, which is able to be the syntax for it. We have the name of the function. We have the parameter that's going to come in, which is word. And we also have the type, which is string. And then we're going to return back the string here as well. So we say if word is equal to Marco, then return back Polo to string. Otherwise, return back no. So it's implicit returns in Rust. So that's it. That's all you have to do. Remember, as I mentioned before, I like to do a make format. Why not? Like, kind of make sure it cleans up. Make sure we do a make lint. It probably will have some kind of a problem. Actually, it may not, because it's okay if the library code just does nothing because we haven't imported it. Now, to import it, this is where we need to start pulling in the command line tool library, and we also need to import the library. So what we can do is actually put the correct syntax into our comments. So we'll say a Marco Polo CLI that uses clap derive and imports the lib.rs Marco Polo function. Marco Polo. Now, the first thing I would do, again, what I like to do is look at other code I've written before. So see this, how this is kind of the boilerplate for what I would probably do. So I'm just going to copy this, and I'm going to just riff on it a little bit. So I'm going to paste this in, and I'm going to say a command line tool for Marco Polo. And then I also want to import. So I'm going to say use, and it's going to be the name of my project. So it's going to be Marco Polo here. So if we go here, we're going to say use Marco _ Polo, Marco Polo. See, we're able to use that. And then I'm going to use clap parser. And we're going to, all we really need here is we just need a string. So we're going to get rid of these like that. And this is going to be the name we pass to Marco Polo function. And so instead of message, it's going to be name like that. And then we can just get rid of that, everything else. So basically to pass in arguments, it's pretty intuitive, right? You import the function that you wrote in the lib.rs. We then use clap parser here, and then we put it all together into the boilerplate code. And then all we have to do now is actually invoke it. At this point, because I have so much boilerplate code taken care of, the generative AI tool is going to be super smart, and we can probably just let Code Whisper write the rest of our code for us. Because again, I already did all the work. I know what I'm trying to build. Why not just say like, hey, Code Whisper, take the wheel. Here we go. Let args equal arg parse args.name. That looks kind of what I want, but we want to actually say, let me see here, arg's name. Let's try that out. Let's see what this does. So if we say make format, make lint it. So we made some mistakes here. So we actually want to look. I'm going to look at my other code again. I like to do let args if we want something like this. We want to say if args.encrypt. We want to say if args.name. We want to say like if args.name is equal to Marco. Well, in this case, we actually we don't even need to do an if statement here. Let's just say let args and say args. How about this? Yeah, that actually should work here. Why wouldn't that work? Args.name, Marco Polo. In fact, I think that would work. Yeah, let's try this. Let's just type in cargo run -- help. Whoops. Oh, we need to cd into Marco Polo. Oh no, we're in there. We can say cargo run -- help. How about that? So compile it. And I think I have the same borrowing issue, mismatched type. Oh, expected string, found string, consider args.name. So the compiler is actually pretty helpful, is that we have to borrow this. So we have to say ampersand right there. So, which is nice. Again, we're getting formatted. Let's lint it. It tells us exactly what the problem was. There we go. We got it cooking. So whenever you see an issue like that, we can take it out and we can do it again. Is that if you just read the actual traceback, it tells you exactly what the problem is. It says, look, because we're borrowing that, it goes out of scope. You actually have to explicitly say, I want to keep it in scope. And so it says, consider borrowing here, args not name. There we go. So again, we fix the bug. We put this inside of here and we do cargo run help. There we go. Now we can run it. And we can just do, now notice that this style, which is that you do cargo space run space dash dash, and that this then invokes the command line tool. So if we do dash dash name and we do Marco, I think we don't need a string here. I think it'll just, yeah, see Polo. If I do Bob, no, right? So pretty cool. And the other thing we could do is if we go to target, debug, we can also do Marco Polo dash dash help, right? So you can also always, when you do a debug build, you can also just do it this way as well. You can say dash name Marco, right? So not too bad actually to build command line tools here. So in terms of generative AI, they're not magic, right? They're probably going to get better and better and better, but you still have to be on your toes. You still have to understand the language, and that's again why I like the style of always making sure that when you get a generative AI suggestion, you do a make format and you do a make lint and even a test. In fact, let's do this. Let's build a little test here real quick. So one of the things you can do very easily with Rust and with generative AI is that you can actually build inline tests inside of your library code. So let's actually do that next. Let's just say, look at this. It's so smart. It's reading my mind that it knows I should write a test. You're right. We need to write a test for Marco Polo. So, okay, let's build the boilerplate code here. Let's test Marco, and let's assert that Marco will return Polo and Polo will return no. Yeah, I like it. There we go. And I think we're missing a bracket here, right? There we go. Yep, there's closed. Okay, and then what we can do next here is we can do the make test. So let's run it. Let's type in make test. Make test. There we go. We see that one test actually passed. So again, in my opinion, the Rust language is such a great fit for generative AI because of the fact that you can actually have so much robust security around this language, and that everything is kind of building on top of each other. So the only other thing we need to do is that I can ask, like I can add a Marco Polo. In fact, I think I have inside of here. Let me look at the get ignore. Let's use, is it Rust data engineering get ignore? I think I need to do target like that. That's what I was missing. I just need to do a blank target so that all targets, period, we don't want actually to be checked in. So I'm going to go back up a directory here and say get status, get add.get ignore. Let's go ahead and check this in. And let's go ahead and commit this, adding Marco Polo. Yeah, we were able to check this in. So really the main components here, again, that I recommended earlier are the cargo, the library, you add the lib, you actually build your logic right here, you put in a little test here as well, and then you've got basically a whole completely packaged tool here, and easily you can distribute that binary to other people. So that's a huge advantage, in my opinion, over Python. And then the speed. So that's the hello world. But let's build something like a little more cool. And so what we could do next here is actually take a look at some of these examples I have in this Rust data engineering repo. And you can see here, I've got tons and tons and tons of examples here. And so one of the ones that would be kind of fun to play around with maybe would be like like polars. And so if we take a look here at polars, let's go ahead and take a look at polars Rust. So a lot of people are talking about, hey, can I use Rust here to build like lightning fast data frames? And you can. A lot of people are switching from pandas to polars just because of the speed here. And if we look at, in fact, the benchmarks, you can see here that basically the lower is better, and you can see that polars is in purple, and pandas is in green here. And you look at like pandas is just wildly slower, like just amazing how much slower it takes versus the polar solution here. So if you care about speed and size of your data, it's going to be tough to make an argument that you should use pandas. And also in-memory data lowers data as well. Look, you can see polars just low here. Pandas just super, super slow. And so fortunately, though, with Rust, you can see here it's not too bad to actually do stuff in Polar. So let's take a look at this example that I have over here. Is that, notice what I did is I have the iris data here. That's a CSV file, and I have the Polar's Hello World code here as well that we can take a look at. So I think what I can do is actually just recreate this project inside of this environment. Let's just kind of build it step by step, and we can see the source code here. We have a main that does some kind of calculation. So what I'm going to do is I'm going to do everything I did before. I'm going to say cargo new, and we can call this basically Polar's Hello World Code Whisper. There we go. And then I can cd into there. And I'll do the same thing. I'll just copy a makefile here. And then we need to start adding the library. So inside of cargo.toml here, we actually have this dependency, which is right here. And then I would need to actually create like a data directory. So we'll go ahead and do that next. We'll say make dir data. And then inside of the data directory, I have like an iris CSV file. So what I'm going to do is I'm going to say touch data iris.csv. And so let's go here and let's just grab this, paste it in. You can see here, this is the kind of famous iris data set here. And then what we can do next is actually wrap it together by writing our polars code here. So in order to do that, I'm gonna move this over here, and I'm going to get into the main file here, and we're gonna start writing it out. So we're gonna say here that polars hello world, and we now need to import it. So we need to say use polars prelude, right? So that would use the polars library, and then we're going to actually do some kind of thing with it. And so we can do like maybe like a calculation or something like that, and we can say, fn calculate. And what we can do is basically say that we want to return back a data frame. So we'll say we want to return back a result, which is going to be a data frame. A data frame. Whoops, we don't want that. We want a data frame and polars error. polars error. There we go. And then we can say let the data frame equal CSV reader from path. That looks good. But we can actually do these like pipeline operations here. So we can say dot has header would be 1, which it does. And I think we can actually tab this over. And then we would say dot finish here. And we could also say lazy if we wanted to, right? To do like a lazy query. And then we could collect, which would run everything. And then we can just return back the data frame. So that would be essentially like a, basically like, hey, how do I operate on a CSV file type demo? And then to pull it all together, we would go here and we would say, let's go ahead and make a new data frame. So we'll just say, let's, how about even like calculated DF? How about that? I like that better. And then we can just print it out. There we go. And if I just need to close the bracket, which would, let's do a shape. Sure. Why not? And let's close this out. All right. So now I can say make format. Let's format it. We got a problem here, which is that I am missing, what am I missing here? Calculate. Oh, I'm missing this. There you go. Perfect. Let's go ahead and format it. And let's just do make lint. If the lint passes in Rust, typically you're in great shape. What does this say? No method name has header, true. So I think, are having some kind of an issue. Oh, is it this? Is that what we're missing here? Let's see if that's actually going to screw things up. Oh, okay. And cargo, let's just do cargo run. And let's see what happens. Okay, still compiling here. There you go. So you can see here as well, we got a good example of how to actually pull in one of the fastest data frame libraries in the world. Not too bad, not a lot of code, right? It's only less than 20 lines of code to pull that in. So I'll do the same thing. We'll just go get status here and go up a directory, get status, get add polars, get commit, adding Rust polars code. All right, so we have maybe a little bit more demo stuff we could do for libraries here, which is what else we got here that would be kind of fun to play around with, which is maybe a how about, I guess we could try this one, maybe like a web crawler, Wikipedia. So if we look at Rayon, this is a library that can do true multiple threaded code. And so if we look at the source code here, what this does is it uses Wikipedia to fetch pages, process the page contents, collects the timing metrics, does concurrent page processing, and then shows the crate usage and concurrency in Rust. So this looks like kind of a fun one to play around with. So let's go ahead and I'm going to go ahead and build this one out as well. So we'll use, and I'll just briefly talk about Rayon as well. If we go to Rayon, Rayon, you can see that simple work stealing parallelism for Rust. So this is data parallelization library that makes it easy to convert sequential computations into parallel. So this is really pretty awesome, actually. And if we look at the two ways to do it would be to parallel iterators. And look at that. I mean, that's awesome, right? Look how simple that is. You just basically, do a for loop or some kind of iterator, and it spawns threads automatically and handles them in a clever way, like looks at the cores you have and does all the work for you. So pretty awesome and a great way to do parallel work. So that's what we're going to use here in this next example. So what I'm going to do is do one more. So we'll say cargo new. Let's actually close all this stuff up. Go here, close this up, close this up, close this up. And cargo new web crawl Wikipedia Rayon, like that. Cargo new web crawl Wikipedia Rayon. There we go. So let's go ahead and cd into this. And from here, I would just need to go to this repo, go to cargo, and actually start putting in the right library. So I think, well, first of all, let's also copy a makefile. Go here, makefile. And in terms of the cargo, we just need Wikipedia equals, and I think 0.3.4 maybe. Is this the latest one? Oh, there's 4.0. Okay, we'll do 4.0. And then we also want Rayon is equal to 1.7.0 last time I checked, but it looks good. 1.7 dot. Oh, 1.8. Okay, there's 1.8. Let's go 1.8. Let's go 1.8. All right, and then let's go to a main file here, and let's start building this thing out. So first, we want to put the context for what we're building. So we're going to say that uses Wikipedia crate to fetch pages. And we can say basically process the page content. Next up, we want to collect timing, also concurrent page processing, and we also want to do like memory, things like that, and shows crate usage and concurrency in Rust. How about that? Looks good. Okay. And so now in order to do that, we need to build a little bit more stuff than what we would typically build. So first, let's import the library. So I'm going to need to use Rayon here, and prelude. So that does the parallelization. We also want to import Wikipedia. We're going to need to do use Wikipedia and HTTP, and it's going to be default client. So we'll have a client for Wikipedia, and then we're going to say use Wikipedia page. And I think those are the 4 imports we care about. And then next, we want to build a struct. So we'll say a struct for process pages, right? So this is just a data structure here that we're going to use that will have the process pages. And I think we'll just stay with title and content for now. That looks good. And then we also do want to actually like pick the pages, like which pages do we care about. So we're going to say const. We're going to do like 9 top NBA players. So let's go ahead and go here and let's say const pages, which is going to be here, and we'll just say right. So whenever you're doing a const like global variable, you want to actually pre-allocate how many items will be inside of it. And so in this case, we can do, let's do Giannis and then we can do as well James Harden. We can do Russell Westbrook. I mean, we could probably freestyle a little bit on this because of this is something Gen AI is pretty good at. We could do Kevin Durant here. We could do LeBron James. We could do Kobe Bryant. We could also do Michael Jordan. Here, Michael Jordan. Right, there we go. And then maybe Shaquille O'Neal. That looks good. And then we would just close this thing out like that. Looks good. All right, so let's go ahead and now process the pages here. So we'll just say fn process page, but we're going to need to do, it's going to take a page and it's going to do a borrowed page with a client, and it's going to return back processed page though. We're going to do this. We're going to say processed page. And we're then going to say let title equal page.getTitle. But we want to unwrap it. Let content and unwrap it. And then we'll just, get the process page here next, which would be title. And we'll say data would be content. And we just need to close it out. There we go. And then finally, now we just need to build this thing, time how long, time how long to process here. And so we can do a main function, fn main, and we can just say let start standard library time. So do a timer, create a client, let the pages be actually we could probably do, we would want to make this into, I think, a vector so we could iterate through it, which I think we can do this vector equals pages, and then we can return, and we can say dot par iter. So this is where you can start to use the parallelization, which is pretty cool. And then we would do something like map. Now the map, though, if I remember correctly, would be, we also need to borrow that. So we would do this Wikipedia dot page from title p dot to string. Does that look right? And then we would say dot collect, I think. Looks good. And then we can say let process pages equal the vector of processed page dot par iter. And then we would say for page in process pages, and then we could go through and kind of loop through this thing, and we could say let start page is equal to timer, and then we could print. So I'm just gonna save some time here, and I'm gonna just throw some stuff inside of here, and then we just need to close this loop out, which is here, and then we just print out our statistics at the very end, and then we're good to go. There we go. I think that should get us. Let's do a make format. Line 43, we have some kind of issue, which is expected. Oh, because if I remember, it should be let's start for 43. It should look like this. Should be something like that. Make formats. And so we can do, just to save some time here, because there's a lot of print statements and weird stuff, I'm just going to replace it. There we go. And make formats, and let's run it. So cargo run, does it compile? And I must have 8 things in there, which is pretty funny. So that's easy to fix. There we go. And a similar one exists. So in the main 51, we have another bug, which is cannot find process page in this scope. And let's see here. Process page, let process page enter. A struct with a similar name exists process. Well, regardless, I think live demos, if you have bugs, just move on. Anyway, this is close, but basically you can you can do an iterator pretty easily with Rayon, and there's a little bug that I need to fix. Okay, so this is a good timer here to move on to our last session, which is getting into mixing Rust and Python, and then I'm also going to cover AWS as well. And so let me do a timer for 15 minutes, and then I'll be back. I'll be back then. So let's do a timer. And if I remember correctly, here, the one I liked before was this one. Let's do that. There we go. So let's do 15-minute timer. There we go. See you in 15 minutes. We got audio now. Okay, so basically, what I'm going to cover today is I'm going to cover the Rust Lambda, and I'm also going to cover Python in Rust. And so I'm going to mix with this one first. So let's go ahead and start with this one, which is the Rust with Python. Go to 16 core, and you should be good to go now, and be able to hear me. And we'll go ahead and say create code space. You should. Okay, and we'll do this. So we can see there's a few different patterns here with Rust and Python that I was able to enumerate here, and I think there's some interesting ones in that basically with Python you get the ease of use, but with Rust you get the power. And there's some interesting ways to mix these two things together, and I'll be able to show this when this thing wakes up. I guess the other thing that's kind of cool about code spaces is that there is actually a lot of advantages to using something like this, because it makes working on a new project a lot easier, right? Because I don't have to worry about, there's less chance that there's going to be some kind of weird error with my project. So if I go to here and I go to themes, color theme, we can go to this. There we go. So let's take a look at some of the different things that we can do. So we can start off with potentially the data conversion here. So if we look at this project inside that, we have Pyo3 dependencies. In fact, it's interesting. It already updated, so we can do 2.0 there. And if we look at how this works, is that the way that you would do a conversion is that you would say use Pyo3 types PyDictionary, wrap the function. And so in this case, we say demonstrate conversions between Rust and Python data types. And so we use the PyFunctions syntax here, and we say, look, this data type here, we want to actually create a text string called hello Python, an integer. We want it to create a float and a Boolean, and then we're going to actually create a Python dictionary. And then we're going to actually, in the Python dictionary, we're going to put the text, the integer, the float, and the Boolean inside, and then we're going to return back a Python dictionary. So that's pretty cool, right? That we're able to actually get that cooking. Now this, okay, then we were able to fix that. So if we go into data conversion, this is just a library, right? Like we're not actually doing anything. We can actually just type in cargo run. We can say cargo build, and that will just build a library. Because yeah, it's true. In this case, there's no bin target. Now there was one. Oh, there's a problem in that cannot find Python 3.9. And so if I remember correctly, you have to actually, let's see here. Is it, yeah, so whenever you, I think in order to start a new project, you have to actually activate Pyo3. So let's do that if I remember correctly. So what we need to do is we need to say which Python. So there's no Python. That's one problem. Or which Python 3, is that it? Okay, we have Python 3. So we can say, is there a virtual environment here? I mean, again, this is one of the things that's annoying about Python. So I don't think I have one. So let's try it real quick. Let's just say Python 3-m venv. Let's just try that. Of course, I have to actually install things, and it's surprising how complex Python really is that compared to Rust. There we go. Okay. And we'll do that. Let's source it. In fact, we could be lazy in case I don't want to get burned again and do this. Well, there we go. And so now it should reload automatically. Now, I think the only other thing I needed to do was to do this. I think you have to install that. Once that's installed, now if I type in cargo build, I believe it will work, if I remember correctly. Well, live demo, could not compile data conversion, cannot find, because which Python 3, not sure why I can't find it, to be totally honest. But did I have to install also, isn't pip install py03 maybe? No, py03, is that it? What am I doing wrong here? Pip personal maturin. We got this maturin to prepare packages. What happens if I do maturin develop? Maturin develop. What does that do? Okay, I think that's how you do it. I just was misremembering the command that you had to do. So instead of doing cargo build, you actually have to do mature and develop. And then, if I remember correctly, I would type in Python. And let's follow the guide here. It's going to say, let's just copy this so that I can kind of look at what I probably need to do. Is I need to do something like this. So we need to do, in this case, it would be imports. Let's look at the example. So source lib.rs. Oh, I see. Py03 example. So what's it would be data types example right here. So let's look here. It would be import that. No module name data types example. What am I doing wrong here? Data types. Let's look back here one more time. Machine develop. A lot of output. Let's look one more time what the, if I do the mature and develop again, mature and develop, it says, Python will fail if you're using check that data couldn't find symbol. Oh, well, there you go. Well, there's some kind of weird problem here. I see. So I actually already had a makefile. This is so long. Oh, that's what I need to do. So I'm gonna follow my own makefile. That's why I like makefiles. So we're gonna say make init cannot run on existing project. We can't do that. So we can say make build. So it's gonna say cargo build release. It's gonna copy this file here. Let's make build. Does that work? Cannot found. Well, I have some kind of weird build process issue where it should be able to create a file here. let's try one more example and let's see if I can get it to work. Which is, I could just have some kind of environmental issue. Let's see if I have another example. Data conversion, digits, pi. So this one looks interesting. Let's see if I can get one more to work. If not, then it is what it is. So if I go to digits, pi, I could even read my own documentation. Looks good. But if we go to this make file, we have a digits pi. So let's cd into digits pi. And then if we go to the source, we've got a lib, calculates a pi function, Python module implemented in Rust. So let's run it. Let's just say make build. What happens? If this doesn't work, there's probably some kind of weird environmental issue. I cannot find Python 3, but it should be able to find Python 3. So there's some kind of toolchain issue here that I'm screwing up here. Linking. Well, I guess this highlights one of the issues that can come up with when you mix Python and Rust together is you're now mixing two totally different environments. And I don't do Python and Rust every single day. So there's some kind of installation issue that I'm going to not care about. But let's see if we can try. Maybe, I mean, the last thing that I can try is I'm curious if my local machine works. So I'm gonna go really quick here to my local machine, and let's go to what is this repo called again? If I say git remote -v, so it's going to be Rust with Python. Rust with Python. Yeah, I think this could work. Let me just look here. So I'm gonna switch gears to my local machine real quick just to see if this will work. rvmv, and then I'll share that out. rvmv. Okay, source rvmv bin. Okay, so let's do this. Let's switch to this thing, and here we go. Oh, wrong repo. So let me let's see here. Change into Rust. Rust with Python. There we go. And then let's change this to here. Okay, let's try that. Let's try this out. So I'm assuming at one point I had this working, but I believe, so I just created a new virtual environment. And let's try one of these again. Let's try the digits pi thing. So if I cd into it and I go to this make file and I type in make build, does this do anything? Well, that kind of looks better. CP target, because at least it looked like it compiled. So if I say cargo build dash release, let's just do that. Okay, it released it. And then let's see if we look inside of the target directory, we have a release. We have a libdigits. Did they, maybe the library changed or something. Libdigits, I don't see a libdigits.so file though. I just see a releases, libdigits.py. Huh. So I don't know, did they change the structure of things? I'm not 100% sure here. This looks like it's the right version, although I guess there is a 2.0 now. If we run it again, let's see. But I guess the idea is that you're supposed to build your code and it should populate here as a shared library, and then you can import it. So for whatever reason, I'm having issues with this, but not that big of a deal because I actually have a lot of stuff that I can cover, including I was going to cover Rust with Lambda anyway. So let's just shift gears to Rust with Lambda. So I'm gonna go to that repo next here, which is Rust Lambda. Let's go to AWS. Let's go up here. AWS Lambda. Rust with Python. AWS Lambda Rust. There we go. That's what we want. And then this editor, we can say open folder, and we can go to AWS Lambda Rust. There we go. Okay, so what's kind of cool about Lambda is that you can build these like really cool functions that do things in Rust. And if we go to, let's say, Marco Polo, that would be a good one. Let's look at the general structure here, which is that when you build a new Lambda function, you have the request, you have the response, you build out your logic, and then you put the logic into the handler, and then this is basically boilerplate code. The thing that makes it really awesome is this library called Cargo Lambda. And if we look here, we could just type in Cargo Lambda new. If I remember correctly, we can actually go to Cargo Lambda and pull this up. Cargo Lambda. If we go to here, web page, for example, I think we can just open up a web page right in here. Oh, simple browser. Check this out. So you can see Cargo Lambda, Rust functions on AWS Lambda made simple, run, build, and deploy Lambda functions, etc., etc. So the guide shows us exactly how to get working. So first step, what do we need to do? We need to do Cargo Lambda. And so if you're on a Mac or even Linux, you don't even have to use Python. The Python ecosystem is not great for this, is that you would actually go through here and do a brew install. Once you're done, then to get started is pretty easy, is that you would create a new project. So let's actually just go through the tutorial first here, step by step. So what I'm going to do is I'm going to say Cargo Lambda new. And in fact, we can even do the new project. Let's grab this and let's just paste it. Whoops, that didn't work. I'll just type it in. We'll say Cargo Lambda new Lambda projects. And it's going to actually ask me a bunch of questions about the project. So it's going to say, is this a HTTP function? We'll say no, right, the default. And is it going to be a function that receives an event? No, we don't care about it. And then if I cd into this new Lambda project, you'll see that we have everything set up here if I refresh. new Lambda project, and it will actually go through here for us. Go through here. It will go through here and add all the libraries that we need automatically, which is pretty cool. Now that super fancy cargo thing, I think I do want to install that because it's not here. It's called Crates, I think. Yeah, this one. That's great. It really is nice to have that extension. So if we go to Cargo Lambda, hopefully it makes this thing dynamic. I'm not sure why that extension is not. It's installed globally. I don't know if it has to refresh or something, but anyway, it installs all that stuff for us here, which is cool. The other thing that it does is it puts a main inside of here, and so you can see here that it puts a lot of documentation inside. So this is a made-up example. Blah 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 blah. The runtime pays no attention to the contents of the request payload. So we can just go here, delete that. This is a response. Again, you can change this to be anything you want, depending on what kind of thing you're writing. And then this is the main body for the function. So basically, the only things you need to change when you're building this out would be the request, which is going to get passed inside of the Lambda, and the response, like what do you want it to return? And then this you don't have to do anything with because it's going to call that handler for you. So really, it's just a little bit of code. It's just from line 5 to line 28. That's it. And in fact, you can even make it smaller, right? If you take out all these comments, you can see everything on one screen, and the response is automatically serialized. So we could actually just do our own little hello world here, and we can just say like, instead of command, why don't we just go event here, and then we would have to obviously change that. And we say event, and then for response, we could actually, I guess, take that out, request ID, and we could actually leave in a message, sure, and we could say it could be an echo, basically, instead of a message. Why don't we do echo message? Echo. So we can say echo, and we would say echo. So all it's going to do is basically echo this. Let event message, event message. How about that? Event message. Okay, so we have event message. That looks good, right? This should work. Whoops, whoa. Event message. Now I do like this, and then this one will be, instead of command, it's going to be event message. Event message. There we go. And I'm going to just copy like another makefile from something I have up here. Makefile there. Okay. And at this point, we just follow the instructions. So if you want to serve the function locally, you just do this. You just say cargo lambda watch. So with cd into, or no, we're in there. So we just need to do this. That's so annoying that doesn't, I guess this simple browser is not great for Visual Studio Code. We just say cargo lambda watch. There we go. So it's compiling it and watching it for us, which is awesome. We can just open up a new shell here. I mean, I guess, actually, you know what I'm going to do? I'm going to close this. I'm going to split screen it and do it that way. And I'm going to say now to test your function locally, the invoke subcommand can send JSON payloads to the function running locally. So we just need to basically do something like that. So we can actually say cargo lambda invoke dash dash data ASCII, and we just need to put in our command here. And so what I'm going to do is I'm going to grab it from another page, because I don't, that string is kind of annoying and I want to not make it. So I want, here we go. No, it's not going to be command though. So we need to look at what our input is. It's going to be echo. It's going to be echo. So we go through here and we go echo. And we do Control E. Let's see, what am I, deserialization and echo. What am I, or is it event message? What is the name of my, event message. Yeah, what am I talking about? Echo. I wrote the code. I should know this. Event message. There you go. Echo hi. Right. So we're able to actually call this thing and get it working. So the next thing to do would be to basically deploy it. So how would you deploy it? And this is where I think somebody asked about compiling to ARM and all this stuff. Yeah, you can look at this. You can actually save a lot of money and actually build a ARM 64 release. So what I'm going to do is exactly that. So I'm going to go here and I'm going to say cargo lambda build release, and then I'm going to say dash dash ARM 64. So we're going to say cargo lambda build dash dash release, and we'll say dash dash ARM 64. How about that? And there we go. It's going to build it for ARM. And then all we have to do is do a deploy. Cargo lambda deploy. It's ridiculous how fast this is. Look at that. So, I mean, it's amazing versus, let's say, Python. And then all we have to do is actually invoke this thing remotely. You can also do it in GitHub Actions, for example. And now to invoke it, let me look at another one that has a make file. Oh, here we go. You do just remote. So we would actually, let me kill this one because it's kind of annoying. There we go. So let's just run that. So let's just say that we're going to type in cargo lambda invoke dash dash remote, and this is, what was the output before? It was I think it's going to be the name of, let's do history. It's going to be this command, but I'm going to have to put dash dash remote and then the name of new hyphen lambda project, new lambda project. And I think it's because the name of it, if I remember correctly, was like 3 or something. Because was it 3? I don't know. I think because this lambda has been created before, that could be causing an issue. But I'm curious if I just do this, if I just say hello October 12. How about that? 2023. Let's try that. If I rebuild it, if I say cargo lambda, and then I do a deploy, it should make a new one. There we go. And that's what I actually want to call. We can go to this one. There we go. Perfect. So that's awesome, isn't it? That you can actually very easily make lambdas, and they have super fast deploy, and you could do ARM64. So I think I'm going to call it a day. I think that was enough. I got almost everything working. I flailed at Python Lambda integration, which, who knows? Sometimes you make mistakes. But other than that, I think this is a good overview, hopefully, for people that if you are afraid of using Rust, honestly, it's not too bad. And if you're a Python programmer, jump right in, and I hope to see you again in the future. If you want to, get this kind of content, there's a lot of it available on Coursera as well. I'll throw a link into here. There's a ton of specializations that I'm building up here. I can actually share my screen here to so if you look at Coursera, no, not that one. We want to remove this one. We want to say share screen. This is where I've been kind of focusing a lot of my time, is actually on building stuff out here. And I have, I think 20 something courses built here. And there's actually, if you want to, if the Rust that's currently out is actually inside of the DevOps, DataOps, MLOps course. There's actually some of this kind of material is actually inside of here, and you can take a look at it. It's all part of this MLOps specialization that I built out recently. Also, you can go to YouTube. I've actually got a lot of content onto YouTube as well. So those are two sources that, if you want more of this kind of stuff, check it out. Otherwise, thank you very much for the people that stayed till the end. And that's it for me. And I'll talk to you in the future. All right. Bye.